While we're studying movement, it's time to have a look at some robots. Robots inspire the imagination. The film I, Robot was very successful. You've all grown up with robots in various kinds of science fiction fantasies, everything from the HAL in 2001, A Space Odyssey, to these mass-produced clones. And robots, while the idea has been around for a good while and continues with older ideas of things like the golem, they're largely a creation of human imagination. After the Second World War, again, once industrial production ramped up again and the computer metaphor got totally instilled in the collective imagination, people started dreaming of intelligent machines and robots they imagined would have a humanoid form would display that intelligence. Now, elsewhere in this module, we've pushed back on that notion of intelligence, which is not a simple notion. There's a bit of narcissism on our part. It's worth remembering that robots are real and they look like this. They're used in factories, they're just moving machines. If a machine has a domain of movement of relative autonomy, we call it a robot. They're not by any means necessarily humanoid. And cognitive science is not particularly interested in industrial manufacture. We have learned a lot from robotics, though, because this was an area in which notions of control and notions of coordination could be tested. If you think you have a theory of how something moves or what the role of a controller is, a good challenge is to build one. And so it's mainly in the domain of locomotion that great progress has been made and that the biggest challenges were. You can see Asimov, the science fiction spaceman-like Japanese robot there, or is he Korean? I forget. It was lousy at climbing stairs and very embarrassingly fell over during this demo. On the left, you can see a passive walker developed using the same kinds of principles that we saw operative in the decerebrate cat in the last video. And on top, you can see one of the many pragmatic robots built by Rodney Brooks, who decided that this business of 2 legs and a top-heavy body, that's really complicated. Why start there? If you give yourself, as insects have, 6 legs, it's much easier because with 6 legs, you can take 3 off the ground at any time and you still have a tripod of support. So it's much, much easier. Robotics has developed multiple traditions and robots have been used to various purposes. The Asimov robot there on the right hand side, who you see, was mainly developed to satisfy shareholders' interest and generate a science fiction buzz. It's not a sensible machine in any respect. The one on the left there is a much more humble looking object. It comes from a European project called Robot Cub, in which the researchers spent many years and many millions of euros developing a platform for robotics experimentation, which had a body appropriate to the kind of challenges faced by a human infant or a toddler. That's why it looks like a human toddler, and they spent the entire budget on the body, no brain whatsoever. That is, on sensors, on actuators, on manufacturing and engineering joints of just the right kind. So that then, if you later on decide to put in a controller, you've got something worth controlling, a body that has enough smarts and is suited enough to its environment to maybe achieve some competence in coordinated movement. But the imagination seems to be more fired up by Asimov than Robot Cub for some reason. And there's been a divergence here. Japanese robotics, while Japan produces some of the major industrial robots of the very unsexy kind we saw at the start, they also produce these whimsical kind of creatures. And Japan seems to go in for the idea of companion robots rather more than most countries. Clearly robotics is a domain here which inspires childish imagination, as it were. These are creatures out of manga. But it's not only in Japan. We find this in MIT. They developed this robot for a while called Kismet. Now, there were no interesting challenges here in movement. This thing moves its eyeballs and its lips and has kind of a face. And this was built in order to study how people interact with something that looks like it has kind of a face, as opposed to talking to a blank wall. So there's no particular robotics challenges here, but here researchers are investigating the way robots play with our imagination. We are very imaginative creatures. You will have seen almost certainly some very successful recent robotics products. The Atlas robot is one of several designed by a firm called Boston Dynamics, who have been most visible in this field. And when you see the kind of feats that Atlas is capable of, you can see it's come a long way since Asimov. Perhaps this is the robotics dream that we were all brought up to hope for, you think? It's cool looking. There's a big but here. Boston Dynamics is a company that was engaged exclusively in military research for most of its life. And they're very, very good at propaganda. You'll see demonstrations of these robots dancing, singing, playing games. The prototype for this particular robot was built for testing chemical warfare suits, nothing else. It was built for the military to be dressed up and put into a chemical hellhole in order to design suits for the military. So when you see singing and dancing robots of the Boston Dynamics kind, you need to remember that this is a display of technology comparable to the display on the bottom right there of a military organization. And indeed, the end users of Boston Dynamics products are primarily military and law enforcement. There seems to be a great deal of uptick in this, and the propaganda, the singing, happy, dancing robots are very important. Here's a slightly scary vision of dog robots under mass production in China. The public face of this company suggests that these are companion robots, but I have my doubts. I suspect these have end users in law enforcement and military, because that's where most of the work in robotics has gone. It's designing drones, designing autonomous vehicles, things that can be used in warfare. So we need to calibrate our expectations when it comes to robotics. It is an important field in which our understanding of control and coordination has been tested, and we've learned a lot from it. Like all of cognitive science, though, its public representation often trades on fantasies about brains and a science fiction blue brain future. The principal drivers of robotics research have always been industrialized mass production and the military. The dream of artificial intelligence and problem solving that seemed so attractive in the 1960s, which gave birth to the notion of artificial intelligence, was all based around a very white notion of intelligence as being what the white man does best, which is play chess. But it turns out chess is an easy problem to solve computationally. Logical reasoning in structured domains, which Descartes would have taken to be the essence of the human soul, is easy, we can do that. But walking turns out to be spectacularly hard. Doing simple things, doing the things that every child, dog, or ant can do, turns out to be really, really hard. This is a situation known as Moravec's paradox. And it's very educational for ourselves to realize the yawning gap between our dreams and fantasies and the real world that we live in.